Hey, welcome, and we're going to do this is a little video where we're going to talk about tree diagrams. Hooray! So we're going to there are 3 slides here, which is important. So you just click the little arrow and click through the slides. We're going to look at a couple of questions, or basically first of all completing a tree diagram. Then a couple of questions that you guys will be real familiar with trying to answer. And then 2 final questions that are a little bit more tricky that we need to make sure that we really nail. So as I say, just when we get to the end of each slide and I stop talking, make sure you click to the next slide. Okay? Okay, so we've the first part of this is obviously we'll go through this question and work out where we're going to put all the relevant information. What you need, I'm going to try and keep this video short. I think I said to you guys about 5 or 6 minutes, so hopefully I can try and aim for somewhere around about that. Certainly no more than 8. We'll see how we go. So I'll get moving. Okay, so we've got the scenario. Hayden drives to school in his new car 70% of the time and bikes the rest of the time. The chances of him getting a flat tire on his bike and being late for school is 15%. The chances of him having a mechanical problem with his car and being late is 8%. So complete the tree. That's our first task. So we're going to go through and we're going to give these little labels. So I'm going to call this one bike, B for bike, C for car, and 2 other parts are him being late or not being late. So let's call it late and on time, late and on time. Cool, so that's a little thing labelled up. Let's go through and get the information out and start labelling this up. So we've got here that if he drives his car 70% of the time, so I'm just going to call that 0.7, which means he must take the bike 0.3 of the time. Then what we've got is the percentages that he's late. So it says here that the chances of him getting a flat tire while riding his bike to school is 15%. So the chance of him being late is 15%, 0.15. So that leaves 0.85 as the of him being on time. Then we've got the probability of him being late in his car is 0.8. So just be careful when you're doing percentages. 0.8 is not, 8% is not 0.8, it's 0.08. So always be careful of that, and that will leave us 0.92. Cool. So what we're going to do now is we're going to go through and to finish completing this, we're going to calculate all of the different probabilities of each event, being late on his bike, on time on his bike, late in his car, on time in his car. So here we go. I'm going to pull up a little calculator so that I can do this. And let's have a look at it. So we're going to go 0.3 times 0.15, and that's going to give us 0.45. So 0.45. And I've done that wrong, so let's call it 0.045. I'll ignore my little dot for the meantime. Then we need to work out what the probability of him being on time in his car. So 0.3 again, 0.3 times 0.85. Bang. 0.255. So that's the probability that he's on time on his bike. So just over a quarter of the time. So then we've got what's the probability that he'll be late in his car? So 0.7 times 0.08. So just always be careful with that. And that's 0.056. Cool. And then the last one, 0.7. So this is him being on time in his car times 0.92 equals 0.644. So now we've gone and worked out all the probabilities. So that's sweet, eh? So we don't have to worry. These first 2 questions are going to be pretty easy for us to answer. So let's look at them. So the first one says B. This is B. What is find the probability that on a random day, this should be Hayden, bikes and gets a flat tire. So let's have a look and see if we can work this one out. So on a random day, so any day, he bikes and gets a flat tire. So that's this one over here. He's biking here and he's late. So 0.045. So we've answered B. Let's put B just down here, and the answer is 0.045. Okay, so we've answered B. Now let's go to C. That on a random day, Hayden is late for school. So what we need to do there is we need to add the two probabilities for the two events where he is late, because either of those two ways could make him late, either by car or by bike. So we're going to add those two probabilities together. I'll get my little calculator with the bulb, and I'm going to type in 0.045 plus 0.0656, and that's going to give me the answer. Oh, I've just made a small mistake. Let's try that again. 0.045 plus 0.056, and that equals 0.101. So the answer to C is 0.101. So far this has been pretty easy. We've had a look at just using one of the probabilities that we've worked out of a certain event, and then we've looked at a circumstance where we needed to combine two events. So that's pretty easy. Let's go to the next slide and we'll look at a slightly harder situation. Alright, so question D and E. Now these are a little bit trickier. We've got our table all filled out, we're good to go with that, but we need to make sure we're answering these questions correctly. So, given that Hayden is late for school, what is the probability he is in his car? Okay, so what we're actually really looking at here is we need to look at the probability that he is late in his car against the probability that he is late at all. So I'll just remind you that our answer to C was 0.101. So that C gives us the probability that he was late at all. So we're trying to work out what the probability the relationship between the probability that he's late and that he's late because of his car. So what we're going to do for this question is we're actually going to divide 0.056 by 0.101. And that's going to give us the answer. Let me get my little calculator out. And I'm going to go 0.056 divided by 0.101, and you will get the answer. And I've done it wrong again. 0.056 divided by 0.101 equals 0.554, and then it goes 4, 5, so 0.55 or 0.554 I think is probably a correct enough answer. So our answer to D now, and I'll rub out C because we don't need that anymore. So our answer to D is D equals 0.554. I need to make it clear why we did that. So given that Hayden is late for school, okay, so we need to know the probability he's going to be late for school. What is the probability it's because of his car? So we're trying to say, well, we know what the probability of him being late is. We know what the probability of him being late because of his car is. So we need to compare those two, and we divide the probability of him being late by his car, by just the probability of him being late overall. Alright, I know that was a bit new. You can ask me questions about that in class if you need to. Alright, here's the last one, and this one's tricky too. Let's go about this. What is the probability of Heidi, I've done it again, being late in 2 successive days? So 2 days in a row. Now, we know we're going to use our little number again, our answer for C, so that's our key. What's the probability of him being late? That's the one, 0.101. That's our key figure. We need to know that one, because that's the probability of him being late for 1 day. So how could we possibly work out what's the probability of him being late for 2 days? Essentially, what you're going to be doing is repeating, if you're drawing the diagram out again, you'd just be repeating another set of these probabilities, and it's 2 consecutive days, so that he has to be late on the first day and the second day. Assuming that the probabilities all stay the same, we've already worked out what the probability of him being late on any given day is. It's that. So that's the probability to be late for the first day. So now we want to know the probability that he'll be late on that day and the day after. So essentially we're squaring that because we're timesing it by those 2 days. It's a little bit hard to initially get your head around, but if you think about it like a coin flip, on the first coin flip you've got a 0.5 chance of getting a heads. Say we want to get a heads. Now if I said what's the probability, and I could draw my tree, what's the probability of getting 2 heads in a row? I'm multiplying that again. So this is exactly the same. So we know that that's 0.5. And I'm just saying, well, I need to flip that heads again. This is the same thing. You know that the probability of him being late is 0.101. And he needs to be late again. So we're going to times it. So we would time, just like with the heads, we'd times those and we'd get 0.25. So this is the same thing. 0.101, the probability of him being late times the probability of him being late again, 2 consecutive times. Hopefully that made some sense to you, and it's not too hard to get your head around. Times 0.101, and here's our final answer for E. In a different colour, that's alright. 0.0102. I think that's probably far enough. And there you have it. So those problems done. So that's our little talk on probability trees. I said the whole video would be 6 minutes. This slide on its own has been 6 minutes, so I failed miserably. Apologies for that. Hope that's helpful. Any questions, talk to me in class. Ciao.